In this video, we will be graphing the tangent function with a period change and a phase shift and a change in a value. All right, and in the next problem, we'll even do a reflection over the x-axis. All right, before we get started, let's take a quick look and remember how the basic tangent function looks. So that when we talk about the tangent function, just look at the yellow portion for one period of the tangent function. So notice that the tangent function usually starts at 0 and it increases. There is a vertical asymptote right in the middle of the period. This green over here is a second period of the tangent function because we normally draw two periods of the tangent function. Because one period of the tangent function only has a length of pi, as opposed to usually when we've done sine and cosine, one period of the function was a length of 2 pi. But unless there's some sort of a stretch, the tangent function only has a length of pi. So we do two of them to sort of stay consistent with what we've been doing. All right, with that in mind, let's do number 7. So I see that we have a b value and a potential phase shift. So the first thing I want to do is fix the way this equation is written, because we have to factor out the b value. So I'm going to take that 2 and put it on the outside of parentheses. So I'll have x minus. Now to figure out what goes on the inside, I need to take this pi over 4 and divide by 2. So I'm doing pi over 4 divided by 2. Now I've learned that when you divide a fraction by a single number, all you really do is put it in the denominator. So I know it's going to be pi over 8 without really thinking about it. But some students are concerned when I do that. They are uncomfortable, or maybe they can't remember. So they prefer to go back to middle school and say keep, change, flip, which has always bothered me. As a mathematician, I like to say we multiply by the reciprocal. So if so pi over 4 divided by 2 would be the same thing as pi over 4 times 1/2 as we multiply by the reciprocal. So again, either way, we're going to get pi over 8. So that's what I'm going to put. Alright, so now I'm going to put another set of parentheses around all of this. So anytime you have a b value and a phase shift, you should rewrite it so that there should be parentheses inside of parentheses. Okay, so we have this a value, which is going to show up when we do the graph later. We've got this b value right here that's going to affect the period, and we've got this h value, which is the phase shift. So first, the period. The period is always the normal period of a function divided by the b value. So in this case, that's going to be pi divided by 2. So pi over 2 is the period. We will deal with the x-intercepts and the vertical asymptotes at the end after we do the graph. The phase shift. The phase shift is the h value, but it's the opposite of what it looks like here. So since I see minus pi over 8, I know that the phase shift is actually positive pi over 8 to the right. Alright, that's a little redundant, but I want to just emphasize what's happening. Positive pi over 8 to the right. Now, normally, when there's not a phase shift, the tangent function starts at 0, so I put a 0 right in the middle of the graph. But when there's a phase shift, the point that used to be at 0 will now be at the phase shift. So the middle point, if you will, instead of being at 0, it'll be at pi over 8. So that's why I encourage you to draw a number line like this, evenly spaced, But if I were you, I would just go ahead and put that phase shift number right in the middle. Okay? Because we know that the tangent function will be at the midline, starting at the phase shift. Okay, now each one of these marks represents 1/4 of the period. So if I go over 1, 2, 3, 4, this is where the period should end. Okay, so I need to label these x values though. So what am I going to do? Well, each one of these marks is 1/4 of a period, so it would be helpful to figure out what is 1/4 of the period. Well, what was the period again? I forget. Alright, the period is pi over 2. So that means 1/4 of the period is 1/4 of pi over 2. Okay, so that's going to be pi over 8. So pi over 8 is a quarter period. So that means I should be able to add this repeatedly to get the subsequent values. So every one of these marks is 1/4 of the period. So I should be able to add pi over 8 and then add pi over 8 and add pi over 8, and that should give me the other values. So you could think of this as 1 pi over 8. So if I add pi over 8, then I will have 2 pi over 8, and then 3 pi over 8, and then 4 pi over 8, and then 5 pi over 8. Okay, so I'm just going to reduce the ones that can reduce. So 2 pi over 8 is the same thing as pi over 4. 3 pi over 8 can't reduce. 4 pi over 8 is the same thing as pi over 2. And 5 pi over 8 cannot be reduced. Alright, we also need values to the left. So this will be where one period of the tangent function will fall along these x values. But we'd like to do 2 periods of the tangent function. So let's think about if we go to the left, 1, 2, 3, 4, then this should be where the left period of the tangent function begins. And I'm going to continue my pattern of counting. So if this is 1 pi over 8, so going to the left, I'm going to be subtracting pi over 8 every time. So I'm going to be going down by 1. So if this is 1 pi over 8, this should be 0 pi over 8. And then this should be negative 1 pi over 8. And then this should be negative 2 pi over 8. And then this should be negative 3 pi over 8. And again, I put the numbers down here so I would have room to reduce and such. Alright, of course 0 pi over 8 is just 0. And negative 1 pi over 8 is really just negative pi over 8. Negative 2 pi over 8 is negative pi over 4. And negative 3 pi over 8 cannot be reduced. Okay, this looks like a 9 or something. Hold on, this is bothering me. Alright, that's it. So you need these 9 values on your x-axis. Very important. So I'm going to go ahead and erase all this extra work now because it might be in my way. Now we know that in the middle of each period there should be a vertical asymptote. So I'm going to go ahead and draw that now. Alright, so there should be a vertical asymptote right here. Alright, just waiting on my slow computer. Okay, and there should be another vertical asymptote over here. Come on. I drew it. Alright, just waiting on my computer to make it a dotted line. This is driving me crazy. Alright, so there are my vertical asymptotes. Now, once I've labeled the x-axis, put my vertical asymptotes in, then it's a good time to draw the y-axis as well. Now, the y-axis is always going to be at 0. So we can see 0 right here, so let's go ahead and draw the y-axis. Alright, so now that we have the y-axis drawn, it is time to go ahead and draw the graph. Okay, the a value is 1/3. So let's go ahead and mark 1/3 on the y-axis because that is going to help us draw the graph. So I'm going to mark 1/3 right about here. And then if I go down the same distance, this should be negative 1/3. Alright? So, going back to the middle, the tangent function always rises. So I'm going to start here from the midline and rise as I go towards the vertical asymptote. But halfway across, it should be at the a value, so I'm going to put another dot like right there. Alright, so this graph should be looking like this. Alright, that was a little crooked, but you get the idea. Then it picks up from down below and it should be rising to the midline, and again halfway over it should be right here at the a value, so it should pass through this dot right here. So it's going to look something like this. Okay, so that's what one period of the tangent function should look like. Now, jumping over to the left-hand side, starting from this point, it should be rising again towards the asymptote, but halfway across it should be at this a value. So I'm going to put a dot there. And it starts from down below and it should be rising towards the midline. But once again, halfway, which is actually at the y-axis, it should pass through the a value, the negative a value. Alright, so that should look something like this. Okay, so this is what two periods of the tangent function should look like. And now let's go back and answer those couple extra questions that they have. The x-intercept. Let's look at the first positive x-intercept, which is right here at pi over 8. Notice that x-intercepts only occur once every full period, all right, not in between. So if I start at pi over 8, I'm going to hit my next intercept at a multiple of pi, at a multiple of the period. So the period is pi over 2. So I'm going to say n pi over 2. That's a multiple of the period. And I'm going to say that n is an integer. Alright, so it could be like -1, -2, -3, or +1, +2, +3, or even 0. I'll do the same thing with the vertical asymptote equations. looking at my first positive vertical asymptote, I see 3 pi over 8. Okay, so vertical asymptotes, or any vertical line, always starts out x equals a number. So that'll be x equals 3 pi over 8. But then, again, we only get one vertical asymptote per period. So I'm going to add multiples of the period. So I'm going to add, again, n pi over 2. And again, n is an integer. So that is going to do it for number 7. Alright, now this is going to make this video kind of long, but I'm going to go ahead and do number 8 as well. Alright, watch out on this one. That negative sign in the front is going to be a reflection. Before I get too carried away, anytime I see that there's a b value and a phase shift, I need to factor out the b value. So I'm going to do that right now. So I'm going to pull that 1/3 outside of the parentheses. Inside, I'm going to have x minus. Now, to get this value, I need to take this number and divide by the b value. So I need to do pi over 3 divided by 1/3. Well, when you divide with fractions, you multiply by the reciprocal. So this would be pi over 3 times 3 over 1. Alright, so that's 3 pi over 3, which I hope you can see is just pi. So the value that will go right here is going to be pi. Alright, now I'm just going to bring down the rest of this. So I should put all of this in parentheses. So anytime you have a b value and a phase shift, you should have parentheses inside of parentheses. And then I'll write the rest of it. So I have tangent, I have -3, I have y equals all of that. So I already mentioned that this is a reflection. So this is the a value that we're going to need later. This is my b value right there. I'm going to need that to determine the period. This is my h value, which is going to give me the phase shift. So first of all, the period is always going to be the regular period, which for tangent is just pi, divided by the b value, which is 1/3. So that means we're going to have, when you divide by a fraction, you multiply by the reciprocal, so 3 pi. So the period is 3 pi. We'll do the x-intercepts and vertical asymptotes at the end. Now the phase shift is pi to the right. Alright, so positive pi to the right. Alright, interesting. So because of the phase shift of pi, whereas normally the tangent function starts at 0, because of the phase shift, the tangent function will start at pi. Alright, so that tells me that my first point of this tangent function is going to be right here at the phase shift. Now, every one of these marks is 1/4 of the period. So if I go over 1, 2, 3, 4, this should be the end of a period. Now I need to carefully label each one of these numbers though. So it would be helpful to know what is 1/4 of the period. Alright, so 1/4 of the period, so that's going to be 1/4 of the period. Alright, remember that the period is 3 pi. So that means I need to do 1/4 of 3 pi. So 1/4 period is 3 pi over 4. Okay, that's 1/4 period. That means each one of these marks should be increasing by 3 pi over 4. So that's why I'm going to take this and I'm going to add it over and over again to get my other values. Okay, so I need to add pi, and somehow I need to do pi plus 3 pi over 4. Now the way to do that is to make this into like denominators, right? So isn't pi the same thing as 4 pi over 4, right? That's the same thing as pi. But that makes it like denominators, so it's going to be easier. Okay. Let's see, I'm going to pick a smaller ink because these are close together. So I'm taking pi and I'm going to add a quarter period over and over again. So I'm going to add 3 pi over 4. So 4 pi over 4 plus 3 pi over 4 is 7 pi over 4. Alright, if I add another 3 pi over 4, that would be 10 pi over 4. Another 3 pi over 4 would be 13 pi over 4. And another 3 pi over 4 would be 16 pi over 4. Alright, I just added 3 every time. Now I put it down here because most of the time there are some that need to be reduced. So 7 pi over 4 can't be reduced. 10 pi over 4 is 5 pi over 2. 13 pi over 4 can't be reduced. 16 pi over 4 is 16 pi over 4 is 4 pi. Okay, so that is it. So I've labeled my x-axis for one period of the tangent function. Now I need to continue this pattern going to the left because I really want to also graph another period to the left. So here's 1, 2, 3, 4 spaces. So this should be the beginning of the left period. So instead of adding 3 pi over 4, a quarter period, now I need to subtract a quarter period. Subtract 3 pi over 4. So if I take this and go down by 3, subtract, then this should just be 1 pi over 4. Alright, 1 minus 3 is negative 2, so I've got negative 2 pi over 4. If I subtract 3 again, that's negative 5 pi over 4. If I subtract 3 again, that's negative 8 pi over 4. Okay, so reducing anything that needs reducing, I have pi over 4. And then let's see, negative 2 pi over 4, that reduces to negative pi over 2. And then I have negative 5 pi over 4. And negative 8 pi over 4 is negative 2 pi. Okay. I need to see these 9 values on your x-axis. Okay, now I'm just going to take a moment to erase all this extra work, which is likely to be in my way. Okay, now we know that there will be a vertical asymptote right in the middle of each period. So let's go ahead and draw that in. What we need now is the y-axis. The y-axis is always at 0. I don't see 0 on here, but I know that 0 is going to be between negative pi over 2 and positive pi over 4 because I got a negative and a positive. So the y-axis is going to be in there somewhere. So I'm going to go ahead and try to draw my y-axis, even though I just haven't been having a lot of luck with my slow computer. Okay, So let's go ahead and look at the a value to see if there's what I need to mark on the y-axis because of the a value. Alright, so my a value is -3. So that means I need to mark the y-axis at -3 and +3. Alright, so I'm going to do that right now. Okay, so right about here, I'm going to call this +3. And right about here, I will call this -3. Trying to squeeze these in here. Alright, so label your y-axis with that a value. Okay, so now let's go ahead and just do the graph. Okay, so normally the tangent function is always rising. So normally I would start here and I would rise as I go towards the vertical asymptote. However, don't forget that this has a reflection over the x-axis. So it should be upside down. So that means instead of rising, this function will be falling, always falling. So I'm going to start from my midline, but I'm going to fall towards the asymptote. But as I do so, halfway to the asymptote, it should be at this -a value. So it should hit this point as it goes. So I'm just going to make sure that it does. Alright, and then it's going to pick up from up high and again fall towards the midline, making sure that halfway it should be at this a value. Alright, so I'm going to fall, but I'm going to make sure that I'm hitting that a value. Alright, so that's what one period of the tangent function is going to look like. Now looking at the left period, again, it's got to be falling from left to right. So I'm going to start here and I'm going to fall towards the asymptote. But halfway, it should be at the -a value. So it should, got to make sure it goes through that point. Okay, and then it's going to jump up and continue to fall towards the midline again, making sure that at this halfway point, it is at the a value. It's got to pass through that. So I'm just going to make sure that that happens. Alright, so that is what two periods of the tangent function will look like. Soak it in. Alright, now as far as x-intercepts, the x-intercepts only occur once every period. So I like to just pick my first positive x-intercept, which in this case is at pi. So I'm going to pick my first positive x-intercept and start there. But I will have additional x-intercept at multiples of the period. So multiples of the period would be 3 pi n if n is an integer. Okay, similarly with the vertical asymptotes, which also only occur once every period, I'm going to pick my first positive asymptote, which is at 5 pi over 2. Alright, and vertical asymptotes always have the equations that start off x equals. So x equals 5 pi over 2. And then I'm going to add, again, multiples of the period because it only happens once per period. So again, I'm going to add this 3 pi n. And again, n is going to be labeled as an integer. And this was a long video, but that does it for number 8, and that does it for this video. I hope it was helpful. See you next time, guys.